In this video, we're going to look at energy and the processes of photosynthesis and cellular respiration. So remember, all energy starts with the sun, and this is going to be called solar or radiant energy. At some point, animals want to be able to use this energy, but right now, in that form, we can't. Plants, however, can convert that solar energy into chemical energy using a process called photosynthesis. Remember, this process occurs in the leaves of the plants and in organelles called chloroplasts that are in their cells. And the chloroplasts are going to take carbon dioxide out of the air, water up from the roots, and they're going to create glucose and oxygen. And remember, oxygen is a byproduct. So what we're really trying to do is make glucose. When we look at this process, the full equation, we have CO2 plus H2O. Those are my reactants, the things that go in. I'm going to take energy, and then I'm going to turn that into glucose and oxygen, and those would be my products. And the energy transformation that's occurred is I've gone from solar energy and converted it to chemical energy having been stored in the bonds of glucose. So I'm going to give you a couple examples of kind of how chemical energy works here. I kind of think of it sort of like coal. Coal has stored a lot of energy. There's a lot of energy that you can get from coal. Now, in our bodies, we want to be able to take that chemical energy and use it for enzymes. And in this case, I'm going to say an enzyme is kind of like an electric drill. Really useful, but it needs a little bit of energy in order to be useful. Now, the problem is, I can't use coal to directly power my cordless drill. I need to transform the energy that's in that coal into something that's usable for my drill. Something like electricity that can charge that battery. Now in this case, we're going to call this cellular energy. It's energy that can be used by the parts of the cell. And this is going to be the molecule ATP. And ATP fits nicely with my enzymes and allows them to work properly. Another example of this would be to think of glucose kind of like a stock. Stocks are worth money, but you can't buy anything with a stock. You have to transform it into a usable form where you can actually buy things like cash. So again, glucose stores the energy, ATP is where it's actually usable. And I like to think about ATP as like cash. And the process that's going to do this is going to be cellular respiration. Now remember, here's my ATP molecule. I got a sugar, a phosphate, or 3 phosphates, and a base, and it's those phosphates that store the energy. It's stored in the bonds. When I break one of them off, I can get energy back, and that's how your enzymes and everything like that get energy to function. So let's look at the processes of aerobic and anaerobic cellular respiration. In aerobic, it starts out in the mitochondria, anaerobic in the cytoplasm. In both cases, we're going to take glucose and we're going to convert it into ATP. That is the entire purpose of cellular respiration, to take glucose and make ATP. Now in the form of aerobic respiration, I'm going to also use oxygen as a reactant, and I'm going to also make carbon dioxide and water. In anaerobic, I don't have any other reactants, but I'm also going to make carbon dioxide and either lactic acid or alcohol. Lactic acid would be the one that occurs in your muscles. So when we compare the two, they do all of those things, both of them. Break down glucose to make ATP using enzymes and making CO2. However, in many major situations, they differ, especially aerobic uses oxygen. And remember, when I say lots of ATP versus little ATP, another way of saying that is that aerobic is way more efficient. And then finally, another name for anaerobic respiration is fermentation, and we have lactic acid or alcoholic fermentation. So if we compare the two formulas, we both start out with glucose. Aerobic adds oxygen, so those are my reactants. They both make CO2, H2O in the case of aerobic, and lactic acid or alcohol in anaerobic, and they both make ATP. Those are my products. And in both cases, I've gone from chemical energy and transformed it into cellular energy. So if we look overall at the full energy transformation that's occurred, I started with solar in the form of sunlight, and then I transformed it through the process of photosynthesis into chemical energy in the form of glucose, and then I transformed it again through cellular respiration into cellular energy in the form of ATP. Now, these processes also involve an exchange of gas. So, if you remember, the chloroplasts need CO2 from the air, and they make glucose and oxygen. The mitochondria then takes that glucose and that oxygen and uses it to make ATP and CO2. So if you notice, the products of photosynthesis are also the reactants of cellular respiration and vice versa. And so these processes work together to exchange gases. Here is a chart that basically shows all that information. And if you know this chart, you can fill this out, then you're pretty much good to go on this topic. And that is, in a nutshell, energy and the processes of photosynthesis and cellular respiration.